Okay. Think we're ready to go. Should get a count in or something. How's it going? Welcome back for another week. I'm your host tonight. I'm Agent Ultra. And on this stream, I typically build stuff in software with the language Haskell. We do a lot of functional programming here. Not always, but usually. And for the past few weeks, I've been working on, well, maybe actually more than a few weeks now, a client library for a database called TigerBeetle. What is TigerBeetle, you ask? I'm glad you asked. It's a financial transactions database. It's written in a programming language called Zig. Really interesting team doing some neat stuff. And they're building this neat little database. So I'm writing a little client library for it to learn a bit about the library and a bit about the database, how it works, by writing it in Haskell, because there isn't a Haskell client library for it yet. Also, I work in fintech and stuff, in payments processing and whatnot, and so kind of a little interest in there as well. So yeah, that's what we're working on. Let's get into it. Last week, we made some decent progress on the project. We've got it sending packets through the C library that they want you to bind to in order to write your own client. All right, well, that C library seems to be talking to the database, and it's sending us packets back. And we got the response packets kind of parsing, which is good. But I think there was like something kind of not right with it, where essentially, even though we were getting this like okay response, like the create account okay response, it doesn't seem to be having like a visible effect on the database itself, not actually creating the account. So this is going to be a bit of a debugging session, I think, tonight, trying to figure out what's going on there and finding ways to figure that out. So it's going to be sleuthing work this week. Maybe a bit of coding. We'll see, depending on how quickly we can sort that out and get things going. Okay, so let's get the database fired up. We're gonna go on this side. I gotta cd into there. That's gonna load the Nix environment. Oh, it's pretty quick this time. That's good. We go bin. TB run. Yeah. Okay, and we can tail the logs. See what's happening. Great. Cool. Alright, so if I run our test program, alright, which, if you haven't seen it before, because you're just tuning in for the first time, welcome. How you doing? It looks like this. All it's going to do is run our little create accounts command. That's it. It's going to create one account at ID 0. Now, technically, I believe last week we already went ahead in the REPL and created this account in the TB client REPL that comes with TigerBeetle, so the official REPL. So we should see an error. The error should be like, this count already exists. That kind of thing. But when we actually run our test program here, we'll see that maybe magic will happen and I'll get the error that I'm expecting, but I don't think so. I think we'll get, it was created, okay. Yeah. So create account result, okay. So that's not, I don't think that's quite right. Because we get into that REPL. Look up accounts. Now, don't be fooled, but like ID 0 should actually be there. All right, ID 1. That's the one we created. So, but if we try and say create 2 here instead, just to triple check and prove to you that this is what the problem is, and prove to myself. I haven't really worked on it a whole lot since last week, so gotta jog my memory a little bit, I guess, just to be triple sure. Okay, that said, okay, create results index 2. Interestingly enough, so we look up accounts, ID equals 2, no accounts found. Right, okay, that's the problem. So something about the response we're getting here, we think it's supposed to be a create accounts thing, but I'm thinking maybe it's a different response packet. We're just parsing it this way, and like maybe that's what's going on. And like, yeah, like, you know, like us. So I've been watching Bill and Ted with my others, and it's a fun movie, so I might drop into that once in a while. I don't know. Don't mind me though. Okay. So that's the issue that we're running into right now. And then how to know that, like, this is what's going on here? How can we find out what the heck is happening? And why it looks like it's okay, but it's not? We can either stare really hard at the code and see if the result pops out to us and we can understand. I think the other thing I might try is... Oh, so I'm gonna look at the code first, just to see if like there's anything glaringly obvious. But the other thing I might try is using one of the official clients and creating a simpler program to the one we have with our client and seeing what results we get with that one. And then maybe like we can add some debugging or something and figuring out what they're actually getting from the libtb client, like the C library and stuff. Because maybe like there's some difference there in the bytes, in the structs, and so on and so forth. Okay, so digging into the library, source, database, TigerBeetle, client. So this is like the main area that we're working on right now, the sync client. The sync client is essentially, well, communicating with TB client is like through this C library. And the C library then takes care of talking to the database, because the client library, the clients, it turns out, for this database all speak the, what's called, I think they actually speak like the view stamp replication protocol, I think. That's my understanding so far. I might be wrong about that one. But on some level, they have to speak like this protocol that is talked about on the wire, right? And that's kind of the reason why they want authors who are going to write client libraries for this to use the C library. There's a blog post about it. High performance client libraries, that's it. So they all have to speak the protocol. And we could write a native implementation of a client in pure Haskell, but then we'd have to like also make sure that we're following the same implementation of the protocol that TigerBeetle is using, other TigerBeetle clients are using. And if they decide to change the protocol format itself, even in slightly different ways, we'd also have to match that as well. So using the C library is supposed to simplify this a little bit, but it does make some trade-offs. Obviously, everything's trade-offs. In that, like, it internally has its own thread of execution, right? It's running its own code, and it calls back to us asynchronously. All right, so it throws data back to us through this callback mechanism. So all this sync client is doing really is throwing that command out there, and then looping until we get some kind of packet back from the callback. We're doing that through this like tvar. So like a tvar is what comes from the STL library or STM library. It's like a little transactional variable, and it holds one value at a time. So maybe not the best design here. Maybe that's like part of the problem. I don't know. But the idea with the tvar though is that like we have nothing, we make the callback, we initialize the client, right, and we run the user's, well, we run one of our sync client T functions. These things. A sync client T, the only one we have right now is create accounts, right? That does sync client T. Right. And so this is going to like get all of our state. It's going to get like our tvar and our client pointer, right? Because we only get like a pointer to a reference that we used from the C client library. And we need to make like low-level calls to it through the FFI layer and all that stuff. So that orchestrates all of this and basically like awaits the result. Right. And so it keeps looking at the tvar until it has a result. If it's got something in it, then we return that, whatever that is. Now, the thing is that I think might be throwing this off here is if like when we run the program, right, we see this warning client thing, this line here. I think that might be from the C library. I'm not sure where that's coming from because my code's not writing that. I didn't write that code to do this. But maybe like there's another packet coming in here that isn't create accounts response result thing. Maybe. So how do we get the result? How do we parse the result here? How do we know that we are awaiting a create accounts result and should parse it this way? All right, await result, pure packet. Well, the way the response parsing goes is we have this decode response thing here. So in the callback, right, we get the raw packet. So everything's kind of wrapped in what's called a TB packet, a struct defined by the C library that we're using here. And we pack everything that we in there, both the commands and the results. Everything that goes back and forth across the FFI layer between our two programs here, our libraries. And so we get the result by calling parse results on the packet. Right? What does parse results do? It gets the raw TV packet. This is here. And it calls this decode response function on it. All right. What does decode response do? Glad you asked. We're going to look. So it comes in at raw, I believe. Maybe lower level. Oh, where did I put it? There it is in raw response. Okay, that's where I put it. In the raw layer in response. Okay, decode response. Takes a TB packet. What does it do with TB packet? Well, it looks at the operation field of that struct. So as long as we're at the lower level where we're deserializing or parsing the TB packet from the C code, right, from that pointer, the TB packet operation field, which is like a UUID 32, an unsigned 32-bit integer, that we convert to an enum, and we pattern match on it. And as long as we're deserializing the right number, and we think this field is right, and we're parsing the right thing, this create accounts should be pattern matching on here and like creating this result, which we can see, right? We're creating this result type here, TB create accounts result, create account result index, and create accounts result okay. All right, so we're peeking at the TB packet data itself. Okay, because kind of what we learned about on the last stream too is like the packet data here is packed as a struct. Okay, and so we have a way of decoding that struct or parsing that struct using the foreign function library of this TB create account result thing. So that's what we're doing. We're creating a TB create accounts result type. So that's the type of result here. Right. Technically, we should be parsing a list of these or an array of these, and returning the result as a list here. So this is kind of hacky at the moment because we're only doing one. Like our test program only has one create result, so I just want to make sure that like this is actually, you know, kind of doing the right thing, getting the right data. So we return that. Okay, so this could be one area here that we should want to look at. To make sure that it's actually like parsing that. So let's dig into that. We got TigerBeetle client, internal FFI client. Okay, packet status, and see that's the packet record here. That represents the C struct here that we're wrapping. Okay. And so this data here is where we're trying to get the result out of. It's a void pointer unit here in Haskell means basically void star or the void pointer on the C side of things. Yeah, so we don't really do any parsing with that here. We just say like, okay, it's a void pointer, so there you go. But the TB client response. Packet status, TB operation. Oh, maybe an account here. It's going to be the account specific ones. TB account. So this is the create account result. Just an enum, nothing too special here. Right, and our enum instance on the Haskell side is using the H2 CS or the Haskell binding generating library we use here to use the C constants to parse these. Yeah. So the thing that makes me go here is only that and this might be fine actually. I should probably look this up and learn and understand this, but there's really like two foreign function library interfaces available in Haskell. And one of them, the newer one, will intentionally added this feature that lets you use or depend on like macro generated values from C side, which might be a limitation of the older one. So, but this compiles them. Pretty sure that's what const is for. So, anyways, I was thinking maybe because like maybe. Part of the thing is like these, not the values we think it is when it's parsing this stuff, but like OK would be 0, and there's a lot of other enums where we can parse 0, right? So I don't know. Actually, I don't know if that's. This might be fine. The thing I'm worried about is like on the C side, the data we're getting back though is like, yes, this is a 2-field struct of like two 32-byte values, which, or 32-bit values, which could be packed into, you know, like 64 bytes each, or 64 bits each, which gives us the 128-bit total size. But like that struct could be other things. And just because it happens to have a 0 in the first field doesn't mean it's necessarily the one we're looking for. That's what I'm looking for anyway. Right, and this is the structure that we're trying to parse out from the that data field in the packet. All right, a word 32, and this is also a word 32, which is an unsigned 32-bit integer. Right, and the reason why originally we were using a binary instance for this and trying to like literally parse out 32 bits, but the reason why we went with storable is because of alignment. We realized it was a struct and not just two 32-bit values packed together into a pointer. No, it's actually a struct. So you need alignment because even though they're 2-bit values, they're packed into 64 bits. So word sizes and boundaries and padding and stuff. So like the peak here, that's what we're really concerned about, reading it. Like this code is so straightforward. I don't really see huge issue with that. What's unmarshaled TB account result doing? That's probably just using the enum instance and like yeah, from integral to like convert from word 32 to an integer and then use to enum to get our TB accounts. So yeah. Okay, so the other thing is the actual packet itself. So TB operation is how we know that like they're kind of like actually doing pulse, create accounts, create transfers, look accounts, lookup transfers, get account transfers, get account balances, query accounts, query transfers, get events. All right, so we use this TB operation enum here to create our packet where we're trying to create an account so that the C library knows when it unpacks this and parses it that we're trying to create an account here. And it's also using this in the reply, I guess, is the idea. And so we should be using it that way to like determine what to parse that void star data as. I think that's how it's done. So let's go look at the C code to make sure there isn't any kind of like response or result. Like that's the enum for the create account result. Type deft. Create transfer result. That's the struct, the index and the result struct. That's all the kind of resulty type things. That's a TB packet T, right? So there's our void star data, user data, and the operation, right? And when you look at the submit, we return a TB client status as a result. So you give it a client pointer, which we do, and a packet, right? TB packet. All right, so the documentation here is pretty, says that you submit a packet with its operation, data, and data size field set, right, which I think we do. And then once completed, a completion callback will be invoked. with completion context and the given packet on the TB client thread, which is separate from the caller's thread. All right, return value is TB client OK on success, so TB client invalid if client handle was not initialized or has already been closed. So I think our Haskell code already checks for that. Actually, that's probably something we could do. Right, we get the packet, we just peek at it, we literally parse the results with decode response, and decode response, right, just peeks right at it. The packet is already decoded. So it does inspect the TP packet operation field of that. And if we look at the TB packet, the peak of that operation, we unmarshal it after trying to parse or decode it as a TB operation like word 8, I believe. Okay. So we're only looking at the packet operation, but we're not looking at the packet status. Oh, sorry. Return value, TB client no cancel. That's the return value of this function. Yeah. So submitting it. Sync. Do we get the status here? Yeah, we do inspect the client okay, and then we only await the result when it's okay. And then when we get the result, yeah, that's where we think. So there was not a client okay, we would show that. Yeah. So and if we couldn't parse the result, there was some error there. We would get it on that part, and then otherwise we get the pure response. Okay. So that all makes sense there, I think. Right, chat? By the way, as your first time tuning in, welcome again. Hi. I'm okay with backseat programming or like interruptions and questions, so feel free to like just jump in, ask whatever. Feel a little peppy tonight, so. And not starting the home row. I'm tapping them after taking a drink. Oh, and I did it again. Oh, I was on the wrong window. Heck yeah, doing awesome. Real peppy. Okay, anyway. So that looks reasonable, at least. Nothing super obvious. We inspect the return value of our submit call. We await the result, and we're decoding the result by inspecting the operation. Right, I'm calling the decode function here with our peak. So we're using the storable instance to parse the struct. Technically this needs to be fixed, but that should be it. Okay. So yeah, nothing obvious sticking out to me. So what I'm thinking I should do now is try this with the write a simple version of this with either the C client or the Python client directly as an example, and see if I can create an account and then figure out what response we're getting. Hey, Twitch D. How's it going? Welcome back to the stream. Hello, hello, hello. How's it going, friend? Okay, I think that's probably what we should do. The tvclient.h header file there. As long as I can figure out from the Nix environment the right link paths, I should be able to at least write the C version of this. Yeah, TwitchD, we are making calls to the library, and the library is like our library is calling the C client library, which appears to be calling the database and then sending us a response packet, and we're able to parse that result packet. However, it doesn't seem to be having any actual effect on the database. So I'm wondering if like we're not parsing the right result packet type somehow, or like what's going on. All right, so like I ran this example program. Is there a commit function? I don't think so. There's a client submit. There's this register log callback. Maybe we could do something with that, but I haven't actually wrote the FFI layer to wrap this function, I don't think. And client submit. I'm not sure what this is for, actually. Retrieve the callback context initially passed to TV client init. TV client init echo. So that would be, I think, this here. And I'm guessing that's the first argument to the callback as well. Right, and then you get the TB packet here. I think this is a timestamp. Or potentially cluster ID. Uint 8T star here. That might be... Oh, sorry, UNT, that's the cluster ID. All right. And UNT 32T, I think that's the address. Maybe? I can't remember exactly what those are, but... Look at the TigerBeetle code. Maybe I have that checked. I don't. All right, if we go to clients, see samples, min. Right, okay, so UNT32 is size and data. So I don't know what's in data. I don't know what that is for actually. Oh, wait, huh. I think maybe I'm understanding a little bit better what's going on here. I'm wondering if this packet here in the callback is literally the packet we sent. Because in this run here, where we have the create account results response, I was like, weird, it's 2, right? And okay. And the change we made was in main. And we changed this to 2 and 0. The operation that we're pattern matching on in the packet would be the same as the one that we're submitting. So that could be parsing it that. And now that I looked at that argument on the C side here, this data with the length, I think we're supposed to be interpreting it from there. Okay, do not spam me trying to sell scammers. I ban immediately and report, so. Boom. So yeah, okay, perfect. Perfect. Okay, so I think I think we can fix this now, and then we'll see this actually. Okay, so result, the callback. Here, packet pointer. We don't actually want the packet pointer. We want the data. We're eventually going to want the result data length because it's technically an array of results. Okay, so instead of packet here, we have some of this code, but it's further down. Or is it down in decode result response? It's in decode response, I think. Which is taking a TB packet, which is probably wrong. So let's go into decode result or decode response here. All right, this is the line that originally we're like, but we need that for here. And instead of packet, it was going to be what's that going to be? It's going to like pointer units. It's technically we could cast it before passing it in here, so it's a little bit more obvious. We're not just passing it around and avoid pointer. Although we cast it anyway. I don't know. Let's just do it that way first, and then we'll clean it up later. So actually, I'm sorry, wrong place entirely. Here. It's actually a result. So we cast the void star pointer to TB pointer to TB create accounts result. Then we peek at that, which uses the storable instance to unpack the struct and put it in result. Then skip this. Actually, let's call this just TB response and put it there. Now I'm just going to get GHCID to build this because, like, maybe there's other type errors. And we'll get this going, and then we'll try running it. Okay, like that. We need type applications in this module. And we need that in scope. And cast pointer we need from foreign.pointer. And oh, our cast isn't right. So it's not here. Result data is a word 8. So we don't have word 8 in scope. Ooh, where's it go? Naturals? No, what is it? Faded outward. Blah. That's for the type level one. Okay, and 45. So the result here is expecting either. Okay, so like, yeah. Our sig state type. The decoding. Yeah, TB response is still kind of the one we want there. Which is the fastest way we can do this is just, yeah, constructing that here with the TB response. So with TB create account response. And so we can get that constructor here from response. Create account result response. And we'll just like slap it in there. That should probably be $, or apply. And there we go. And parse results not used. Let's just comment that out. Okay, quick and dirty. Okay, we all compile. Good. Let's try this out. Hell yeah, there we go. Man, Twitch DD. As soon as you come on, it's like boom. Prog. Okay, create accounts result response. This is better. Create result index 0. TB create accounts result. ID must not be 0. Perfect. It's great. This is why I think like more folks should try streaming themselves programming, you know. Maybe not on Twitch if you don't want. I'm looking at even self-hosting, maybe moving over to self-hosting solution, but like, or even if you're just pair programming at work or something, it's such, even if you're introverted, like I'm super introverted, I'm not very extroverted, even though I'm streaming and doing all this stuff, but like, it's such a different experience. And it's really good. It's really interesting what happens, and it's kind of neat and worth doing once in a while. Even if it takes a lot of energy out of you, try it once in a while. But streaming, I think, is a low-touch way, because, like, you don't have the direct intimacy of having another human being in your face. You've got all of stream, which is even better. Okay, so ID must not be 0. So let's go to main. Let's create one with, like, ID 2. Right, recompile, relink, rebuild, run, execute. Hopefully we get ledger must not be 0. Okay, cool. Ledger must not be 0. So, like, our account creation code now. Oh, this is great. This is so good. Okay, so that means we go to create accounts. We create account packet. Here with our create accounts params. Our create accounts params comes from our account module. Here. Right, ledger int. Okay, that's the second argument to it. So let's do that. Let's do 2.1. Cool, cool. Code must not be 0. Ah, yes. Okay, so we're missing an argument here that we need. All right, so I must be able to pass 1. I remember the C documentation. The code says that's the 3 fields we need. Oh, wonderful, wonderful. Love that for me and for us. Okay, pardon me. Here we go. So we get the create account arguments here, and then db account code from integral create account code. Sick. Oh, segmentation fault. Oops. However, looks like things ran. Let's see if that actually affected the database, though. TB-REPL. bin/TB-REPL. Look up counts. ID equals 2. Oh, there it is. Ledger 1, code 1. Okay, ID 2. Ah, yes. Okay, that's good. The segmentation fault isn't good, but this is decent. This is decent. Okay, so yeah. Well, you know, you create more problems for yourself. That's programming. Add some code, more problems. Eventually you iron out all of the problems and you get something just what you wanted, hopefully, at some point in time. Right, so if I run this again, I should get an error type, an error result. Cool. Account exists. That's good. So the seg fault is concerning. I wonder if we can reproduce it or if it was a random thing. Does it only work when we actually create an account successfully? Let's try another one. Could be I'm not freeing something, or something is getting garbage collected that shouldn't be. The C client is then trying to do. Yeah, it just crashed at the end, yeah, so that's probably what it was. Some of these data structures, the C client library expects to be like in a pinned region of memory. Presumably because the C client code is going to be doing its own kind of cleanup code on it and is going to refer to it. And I think it might be the TB packet we get in the callback, but we'll see. Because like all the other cases are fine. Like the error cases all seem to return fine. So can I create an account with the same ID but a different ledger? Okay, we got to use this with different ledger. Okay, so like, so if I create 3, then I'm guessing we're gonna get our seg fault again. Yeah, okay. So it is something specifically with that particular success case when it actually does get created. The error cases seem to be happening fine. Hello, Inoxidus. Welcome to the stream. How you doing? Okay, so I'm going to create a little community commit for this. Oh, I'm going to clean this up and then create a commit for it, but I'll create a work in progress commit for it and then clean it up. Just get rid of that. Yep. Okay, stage, commit, work in progress, fix, create, accounts, callback, or command. Learning Rust, sweet. Rust is awesome. I am great, thank you very much for asking. Do you do Haskell programming at all? Or just curious? Or just looking to chill, because that's also cool. And just stumbled upon the stream. Fix the create commands command. Yeah. Okay, let's clean up that code now, because it's like we know it kind of works. Kind of works-ish. Okay, get rid of the commented out code. Boom, boom. Okay, that's fine. And okay, so what we actually want to do here is not like with client, we don't want to specialize everything to TV create account results. It only happens to work because like that's the one command we're actually running here. This needs to be more general. First, that's one thing. The other thing is something needs to not be garbage collected, I think. So we go to tvclient.h. It's a client submit that tells it. No. I think the tech docs are the ones that like mention pinning. Oh yeah, actually no, here it is right here. So a TB packet is a struct containing the state of a request submitted through the client. This struct must be pinned, not copyable or movable, and its address must remain stable throughout the lifetime of the request. Same with the client T, but I think like this is what we use foreign pointer for throughout the library so far. It could be that my assumptions about foreign pointer are mistaken, but I think that's what foreign pointer does. Rust melted your brain, Twitch D. Some of the more advanced concepts. Oh, like the borrow checker? Yeah, yeah. I've heard that some people who have like been learning Rust, like I've heard some people say, and I don't know if this is true because like I've only done a little bit of Rust programming, that it's getting to the point in Rust now where if you're under the impression that like Haskell and Haskell's type system are like hard to understand, Rust is maybe harder. I don't know if that's true, but I can understand why the borrow checker could be. Just because like if you do any work trying, or if you've done any work with like formal methods, and specifically with like proof assistance, and try to prove things about like C code or like low level code like that, you have to like deal with references and you have to model that somehow, right? And Rust is kind of doing that a little bit. Like that's what kind of the borrow checker is doing. It's like a way of specifying lifetimes of references, right? And that can get pretty complicated. At least I can see how that could get complicated, but again, I haven't used it a whole lot, so but like I have empathy for it. Let's say. Right, so one of these things, maybe in this particular case with our segmentation fault, is getting garbage collected before the C library has had a chance to do what it needs to do with it. And so it's the C library seg faulting. Now I'm not sure how to avoid that here. Okay, well first I'm going to clean up this here. Okay, so the result data is void, but the TB packet at least has the operation on it, and that would tell us how to interpret that void pointer and what the data is we should expect in there. Right, and of course the length argument we're going to need in order to like actually parse the array of results, because everything's like batched. Right. Okay, so I'm going to write a little to-do list for us here. This is going to be a multi-stage thing. All right. Oh, there we go. That's one. That's Control C L. Okay, store link. Right. So we want to parse the result data depending on request packet. Then we need a general way of decoding or constructing the result TB response based on that. So like maybe we can make this into a decode sort of situation here. And yeah. And then the final thing to actually like get this proper is parsing the array. Okay. So let's work on the first one. TV create accounts result is not what we're going to peek, and we're not going to cast to that. This needs to be, we need to move this back into our decode function. So we're going to need to update our decode function. Our decode response should take a packet, the void pointer, and it's going to need our length. The type of that is actually going to be word 32. Yeah, the response level, we can just make it int. Okay. So we get result data here, and result len. Okay. So we still case on the packet operation, that's right. And then result here doesn't, we don't do packet TV packet data, we're gonna convert from the data array, which was in sync, which is actually from word 8. Word 8. Yeah, pointer to word 8. Sigfault could be us. Yep, could be us. This is an array of word 8, and the length is giving us how many of those to parse. Then no, that should be fine. It could still be the C library, yeah. I was thinking maybe there's like a different result type here that we're not initializing properly. But that doesn't make sense. So no, that's fine. Stay on target then. So then this should be result data. And this will be word 8. And we might need data.word. For that, let's get GHCID fired up here. Help us with this refactor. Okay, and yeah, just gonna put an apply in there. And so it's not actually pointer units, pointer word 8. And then, oh yeah. Response here, we call it decode response here, which now needs to change as well. Even though I don't think we're actually gonna end up using this. This is code left from another attempted implementation. which I'm keeping around for now because it probably has like, it's had and probably still has some useful stuff in it. But now I'm having to like maintain it and I'm not even sure it works. Okay, so I could, in order to get this code to work, get the result pointer and result len here. And then we just pass those in. Oh, and we have to like convert that to okay, that's good. Compile us. At least. Okay. So now, instead of this, we can get our TV response by calling decode response with the TV packet, result data, and the result len. Here. And then we don't need all of that stuff. We can just TB response. Not RB response, sorry. TB response. Match expected type TB packet. It's actual type pointer to TB packet. Yeah, that's just a pointer to TB packet, so we can get. I'll use the pointer suffix there. That's all it's used, so then we can do TB packet here, and we'll just peek packet pointer. Okay, and then we have to do the good old from integral dance here. And then we can change our secret results. Oh, that should be fine. 45 here. What was the result? TV response. Right. So you think, so Haskell's inferring that this is actually a TVAR maybe TB response. Because here we're not defining the type of the TVAR, but we write TVAR result maybe. So decode response, type of decode response, maybe. Oh, it's just TB response here. Oh, Did I change that by accident? Maybe I changed that by accident. Or I changed it on purpose and I forgot what I did. Reason commits. No, we just changed account and sync. Oh, it's parse results. Okay, and parse results was returning the either there, but it was just constructing the right. And there's no left there, so it was kind of a vestigial thing. Okay. Right, because we're using the storable instance here with peak and stuff. If it fails to decode that struct, it's going to presumably throw an I/O error, essentially a runtime exception, which is probably not super cool or great, but like if you're doing stuff in I/O, that's kind of like what you have to expect, right? These things can happen. Okay, so that means in sync, we have to change this either by changing the type here to just TB response, maybe TB response, which probably pretty reasonable. And now you are complaining. And you are complaining. Right, because we don't need any of this anymore. We can just await result. Cool. Then we don't need data.word anymore here. And we don't need that or that. Super. Okay, so that should be part one. And if we go running that again, we should get the 0 errors. I think I switched everything back. In the main, at least. Oh, right. And that doesn't even compile anymore, so we should probably fix that too while we're at it. Let's make these legit. Okay, cool. What next? Okay, and then these. Clean up response parsing code. Okay, that closed that. TB response, actually that kind of closed that as well. Yeah, now we just have to parse the array of result data to actually like make this good. Which is going to be in response. Okay. So data.storable. By foreign.storable. These are the class things we get. We get size of, we get alignment. All right, we get peak element offset, which reads a value from a memory area regarded as an array of values of the same kind. The first argument specifies the start address of the array, and second, the index into the array, effectively using the size of, like the alignment offsets. Twitch TD, we're working on that now. We're just cleaning up some of the code. I just finished cleaning up the code and making it general again. So now we're looking into, well, we're looking into one more step in that, and then we'll work back into the sig fault. So I'm just adding, or we can pump the brakes on this one, and then, well, we don't have a ton of time left, so, and I think the seg fault thing will take a while to figure out, so this one will be hopefully pretty straightforward. So yeah, one more step in fixing the response parsing, which is like parsing an array of the result data. So just working on that. So peak element offset, right, uses the size of to like offset into the array a number of elements. Now, depending on this data value, is it given in the callback? Is the completion callbacks argument given in bytes or bits, or is it given in number of elements? Okay. If we look back at TigerBeetle client's examples, it just says size. All right, so create packet calls. I guess they changed the API. This is probably a newer version. Send request or submit packet. If it's not client okay, then we fail. If the TB packet, if it's not packet okay, then fails. And if context size does not equal 0, then we create a TB create accounts result T struct, an array of them, by looking at that. So it is given in bytes. Okay, so we have to calculate the length by doing that calculation. And then we can parse the results out from that. Okay. So, in order to do that in response with decode, simple enough. So we got result len. We want num results, we'll call it, and that'll be result len minus size of tb create accounts results. Okay, and then we can accumulate those using peak elem offset. And how am I going to accumulate those? I can traverse over the lists of indices. One. Goes away the result, collects the result. It says mapping each element of a structure, so like our list, to an action, which is going to be our IO action. Evaluate these actions from left to right and collect the results. And the results should have the same container structure as the same container structure as the thing we're iterating over or traversing over. The T type here. So, a list. So the first argument is our action. But I'm going to flip this around so that this is from 0 to num results. Bring this over to the left a little bit. I'm just trying to make it a little bit more readable here. Get a little do here. We'll get an index. As an argument. Okay, so now we should be able to use peak elem offset to get an IOA, right, in our action here, and then that'll be collected in our results inside the B here, the T of B. Takes the pointer as the first argument. And we're just setting the type here. That's pointer result data. Let me get GHCID going here. Help me out with this. Finish this off. Might not need this application actually. And size of is applied to too few arguments in response. Oh, here. Size of actually needs an A, a storable A. Yeah. Okay. That's... I don't like... that's annoying. So I need to put something in here, an actual value here. Gosh, I wish I could do that by the type. I believe it is TB create accounts result just two numbers, two integers. Cool. Peak element off. Okay, and then 43. So counts result. Okay, and no instance for fractional int. What am I doing here? Wait, no instance for num TB create account result. Yeah, of course not. Do I have like even more? Yikes. Okay, I am doing something silly here. All right. So we don't care about the values here. I'm just using it for size of TV create account result. It's referring to that one. Yeah, qualifying it's going to be annoying. Hopefully not that annoying. Kind of annoying. Yeah, really kind of super annoying. Okay, backing out, backing out, backing out. We'll hide it from there. Okay, that's better. Easier. Okay, that's all good. At least it's compiling. Okay, so that hopefully still kind of works. Nope, does not. To enum cannot match some crazy number. Okay, so we're yeah, our traversal isn't working. Okay. Peak element offset. The first element of the array should have index 0. We have 0. I believe, ranges are inclusive. Come on, Haskell, hurry up. I think that might be inclusive. I think that's probably the issue there. Oh, it's not gonna work that way. I think I think that just might be inclusive. Yeah. Yeah. Okay. So we're just reading over the end of the array there. That's all. So we just need number zones -1. I think that will be it. And then we just have to figure out the... Yeah, there we go. Then we just have to figure out the seg fault. And what's happening there. Right. I think it's still there. Well, let's just see if this actually fixes it. Huh. Might have actually fixed it. We got an empty response list. Let's see if that actually worked. That'd be great if we killed it with 2 birds with 1 stone there, just by making the parser. It was just the parsing of the data. Create it with 4. Ledger 1, code 1. Yep. And there it is. Okay. Looks like we did. I'll take it. Okay, so yeah, I guess how the seg fault in the other case, in the actual creation case. Yeah, we were accessing memory beyond our bounds, and that's what was causing the seg fault, because this peak here I guess in the success case, we don't actually have any data, like no packet to response to read. So the pointer length has 0. So we're actually trying to read a struct beyond the bounds of the array. So we should actually probably look at, just like in the C example in the sample code, look at the length, the result length, before we try to decode anything. This just happens to work with traverse, with numbers 0, whatever. Oh, actually, no. Peak element offset. How does that actually work? No, now I don't know why that actually works. Hang on a second. So if the result here is 0, mix is 0, peak element offset at 0 for the thing. So my theory was that when we actually tried to peak the element in the empty case, in the case like of success, then we're getting an out of bounds address read, which was causing the segmentation fault. Why does that not cause that with peak elem offset? Maybe there's something interesting about the implementation. It's not actually using peak. Or traverse is hiding something there. Because really what I think we should probably do before we even like try parsing anything is if result len is 0, you don't have to return anything. You just have to pure TB accounts create result empty list. But it seems to work. Interesting. Okay, well, we're out of time on the stream today, but I think that's pretty good, actually. Let's knock off that to-do item. And that also seemed to fix the other issue, so cool. Create a commit for that, work in progress. Parse array of results. All right, we're gonna rebase here. Interactively pick those, pick that, squash them all together, and we'll reword. And then finally, I'll call this fix grade accounts command. Call it fix sync create accounts command. So in this we mostly change stuff. Added the code parameter to create accounts. Create account. Changed decode response. No longer returns either. And sync create accounts, parses results properly. That's good enough. Cool. So I'm going to push that up to the repository. So all the code you've seen tonight on this stream is up on GitHub. I'm Agent Ultra on GitHub as well as here and in other places. And this is all on GitHub at Agent Ultra / TigerBeetle-HS. I might have actually still had that on a branch. I repushed that branch, so I'm going to fix that later. But if you want to star whatever, there you go. Thanks for watching Twitch TD. I do these streams on Wednesday evenings at 10 after 8 in the Eastern Standard Time Zone, so I'll be streaming next week as well. You can give me a follow here, of course, and if you have your notifications turned on, you'll get notified of that when I go online and start streaming, or just write it down in your calendar book or whatever. If you're watching on YouTube, where I back up the VODs for this stream, you know what to do there as well. You can like, subscribe, leave a comment. It all helps out, lets me know that there's still an audience for this stuff, and all that sort of stuff is just, you know, general feels and vibes. It's good stuff. So do that there. And what else? Yes, you can follow me on the socials. I am on types.pl in the Mastodon universe and the Fediverse at Agent Ultra there as well. and of course agentultra.com. Both of those have like links to all my stuff, my GitHub, websites, my YouTube channel, and all that sort of stuff. So check that out there. And that's about all I got this week, folks. So thanks for watching. May all your monads be free and your types always check. And happy hacking out there. And enjoy. Enjoy. Keep your head above water. And I hope you're doing well soon.